Okay, Ashley, so we're looking at problem 10b here, and I agree, your teacher's explanation or the way he constructed the answer is confusing, but let's work through it, and I think we can make sense of it. So we're looking at the second derivative, and we only have one concern, and our only concern is over the domain of interest. Is this negative? Is it positive? And does it ever change signs? So negative, positive, or both. That's what we care about. And the domain is the region of interest, or the domain is still 1 to infinity. Because the original function is undefined at less than 1. Okay, so that's a given. That's understood. And if the second derivative is negative, that means it's concave down. Positive means concave up. And we want to find out if it ever changes from one to the other. So is it, and where does it change? So all of those questions are in play. But what your professors or your teacher's saying is, okay, the quick way to see if it ever changes from negative to positive or vice versa is to look and see if f double prime ever equals 0. So does f double prime equal 0 at any point? If it does, within this domain, then we have to pay attention to the fact that the second derivative is probably changing sign. In fact, it is changing sign because, as he points out, it's an odd function. That means it's not going to be symmetric across any vertical axis. So if it's positive at negative infinity, it's going to be negative at positive infinity. Okay, I'm probably trying to explain too much. But anyway, so just to review, the only question is, what's the sign of f double prime at various regions from 1 to infinity? So really one way to do this is just look, okay, whenever x is 1 or greater, the denominator is always going to be positive, but the numerator is always going to be negative. So f double prime is always going to be negative. That's all. But what he's doing is he's kind of going through what you might call a rigid protocol or an algorithm, and he's saying, well, before we look at the sign specifically, let's ask the question, does f double prime ever equal 0? And so the quick and dirty way is just look at the numerator, and he says, aha, f double prime will equal 0 when x equals 0. What he left out was, oh, but the original function's undefined at x equals 0, so this is no longer relevant. But what he is saying is, there's nowhere else where f double prime equals 0. So in fact, over this domain, what he's really showing you is that f double prime of x never equals 0. So that could save you a little time. You could say, well, when I plug in x equals 1, I get a negative number, and I know it never changes sign, so it's always negative. To me, really, the shortcut is just to look at the numerator and say that's always going to be negative from 1 to infinity, and this is always going to be positive. So it's just a matter of personal taste. You can deduce the sign of f double prime without going through this exercise of finding out when it might equal 0, or does it equal 0 during the domain. So I hope that makes sense. If it doesn't, let me know. And I hope you are otherwise doing well.